All right, guys, so this is Unit 1, Quiz 1 Study Guide help video. So let's go ahead and go over it here and see how you guys do. So for number 8, we're being asked to find the y-intercept, the slope, and then determine whether the function is increasing, decreasing, or constant. So for number 8, the y-intercept is -5. The y-intercept is where it touches the y-axis. You can write it as a point, 0, -5. The slope can be found in one of two ways. One way you can find the slope is simply by picking 2 points that are on your line and then finding your rise and run. So if I'm going from left to right, I would have to go down this many and over this many. So let's see how many that is. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went down 9 and to the right 3. And if I make a slope out of that, -9/3, I'm going to end up with -3. So I've got a slope of -3. Now, another way of doing that, if you don't want to do it that way, is you could use the formula approach. With the formula approach, once again, you still need to pick 2 points. This point is 0, -5, and this point up here is -3, 4. And what we can do is we can label these as x1 and y1 and x2 and y2, and we can apply the slope formula, which is y2 minus y1 over x2 minus x1. And we end up with the same thing, -9/3. All right? And then we have to decide whether this function is increasing, decreasing, or constant. And since my slope is negative, or since the line is moving down as we go left, we would say that this function is decreasing. Okay? So those are the 3 parts to number 8. Let's move on to number 9. Okay, so for number 9, y-intercept is 3. That's where it touches the y-axis, and we'll write that as a point. The slope can be found using the graph. You can just pick 2 points off of your graph and look at your rise and run. I'm going to the right 3 spaces, so that's a +3, and then I'm going up 2 spaces, so that's a +2. So my slope would be 2/3. The alternative way to approach that would be with the slope formula, which would require us to, first of all, give the coordinates of 2 points. So in this case, that one is 0, 3, and this one is -3, +1. And then to label them as x1, y1, x2, y2, and then plug them into the slope formula. y2 minus y1 over x2 minus x1. And we end up with 2/3, which is the same thing we got by doing it graphically. So it doesn't matter what approach you use. Next, we want to know, is the function increasing or decreasing or constant? One way you can tell is since it's going up as we move to the right. Another way you could tell is since the slope is positive, both of those things indicate that the function is increasing. Okay, let's go ahead and move on to number 10. All right, so first of all, we want to find our y-intercept here. The y-intercept is the place where it touches the y-axis, but another way you could think about it is it's the y value that goes with the x value that's 0. And in this case, we can see the x value is 0. So that would mean that our y value is 1 there. So our y-intercept would be the point 0, 1. Okay, now the slope, once again, we're going to want to use our slope formula here. So let's go ahead and use these 2 points. I'll call this one here x1 and this one y1. We'll call this one x2 and this one y2. So if we go ahead and put that into our slope formula, we're going to have y2 minus y1 over x2 minus x1, which is 0/3, which just simplifies to be 0. Now we also want to know, is the function increasing, decreasing, or constant? anytime your slope is 0, that means that the function is constant, which means that the graph of this function would look like a flat horizontal line. Let's go ahead and take a look at number 11 here. The y-intercept is the place where it touches the y-axis, but you can also see that it's the place where the x value equals 0. So in this case, that's right here. When the x value is 0, the y value is 4. So that would be the y-intercept. Slope. To do the slope, we're going to want to pick 2 points. It doesn't matter what 2 points you pick, but I'll pick 0, 4, and 4, 12. We'll call this pair x1, y1, and we'll call this pair x2, y2, and we'll apply the slope formula. y2 minus y1 over x2 minus x1 is 8 over 4, which reduces to 2. So I'd have a slope of 2. And since my slope is positive, that would mean that my function is increasing on that one. So that's numbers 10 and 11. Let's go ahead and take a look at numbers 12 and 13. So the y-intercept is the value of y that goes with the value of x that equals 0. So there's a long way and a short way. I'll just show you the long way because it always works. The short way is convenient sometimes. But the long way is to plug 0 in for x and to simplify. And so there's my y-intercept. Now, if your function is in this form, you can use a shortcut. And the shortcut is basically just whatever that number is, the b value, in this case it's 4, that's your y-intercept. So my y-intercept is 4. The slope is going to be the number right here in front of the x, so we'll just use the shortcut there as well. So the slope is negative 1/2. So we have our y-intercept, we have our slope, and since the slope is negative, that would mean that this function is a decreasing function. Okay, let's go ahead and do number 13. Now in number 13 we talked about these kinds of lines. This is a horizontal line. It looks something like this. Functions like that are going to have, the y-intercept is going to be the number that they give you. So in this case my y-intercept is 5. That's where it touches the y-axis. But a horizontal line like that, when there's no x present, those have a slope of 0. And then finally, since the slope is 0, that means that this function would be constant. Okay. Now, we talked about these ones too. If it's just an x equals, in those cases, you may not have a y. Well, you really wouldn't have a y-intercept. You wouldn't have a slope either. Your slope is undefined. And you really couldn't say whether the function was constant or increasing. The whole thing is basically just undefined when that happens. So let's go ahead and move on and talk about graphing now. All right, so when it comes to graphing functions, we always start off by graphing the y-intercept first. So my y-intercept is -4. We'll put a dot there at -4. And then we're going to use our slope. Now for the slope, if your slope is negative, that means you're going to go down. And then the bottom number, we're going to go right. So now if that was a positive 3, a positive fraction, we would go up and right instead. But since it's a negative fraction, we're going to go down and right. And we start from this point here. So starting from that point, we're going to go down 3 and over 5. So down 3 over 5 would put me right about here. And then you go ahead and sketch your line. Okay. Let's go ahead and take a look at number 15. Y-intercept is 2. I've got a positive slope this time, so I'm going to go up and right. So I'm going to go up 1 and right 5. And that's what that graph would look like. Let's move on to the next pair. All right, so for number 16 and 17, we have some missing numbers. And so whenever you have a equation in slope-intercept form, you're going to have 3 numbers. You're going to have a rise, you're going to have a run, and you're going to have a y-intercept. Okay, so those are our 3 numbers that we care about. Now, if any one of these are missing, that means they equal 1. So if you're missing a rise, a run, or both, then they equal 1. If you're missing a y-intercept, that would mean it equals 0. Okay, so bearing that in mind, we're going to go ahead and hit up these two problems where we have missing numbers. So here we go. In this case, I'm missing the y-intercept. So that would mean it's 0. And so I would start at 0, and then I would rise 1, run 4. We'll take a look at 17. On number 17, I'm missing the rise and the run, and as I said, they're both 0, and they're both 1 in that case. So I'm going to replace the blank with 1 over 1. And that means I'm going to start at my y-intercept, which is 2. And then I'm going to go down 1 because it's a negative, and then right 1. So down 1, right 1 from my y-intercept would put me there, and there's my graph. All right, let's move on to the next pair. So on both of these problems, we don't have them in slope-intercept form. We want them to look like this, but they're not looking like that. And the way that we get them to look like that is we get the y by itself. So on number 18, to get the y by itself, all we need to do is subtract the 9x on both sides. After that, we're welcome to graph it. So I'm missing my run. That means it's 1. My y-intercept is -5, so I'm going to start down at -5. My slope is -9 over 1, so I'm going to go down 9, right 1. I'm probably going to end up going off my screen here a little bit. We can talk about that. So instead of going down 1, right 1, instead of going down 9 and then right 1, there's a way we can handle that situation, and here's what we can do instead. Instead of putting the negative with the 9, we can put the negative on the bottom. Now, if you don't like this, me changing things up here at the last second, you could just make the graph longer. It doesn't matter to me. But I just want to show you what you can do if you do end up having to go off the graph. So instead of putting the negative on the top with the 9, we can put it on the bottom. So if I put it on the bottom, what this means is that the top is now positive. So that means I'm still going to go up, but now that the bottom's negative, my run is negative, which means I'm going to go left. So an alternative way we could do this then is starting from my y-intercept, I can start at -5, and I can go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then left 1. So that's another way we could do it. So if you ever end up going off your graph, then you can just make the bottom of your slope negative instead of the top and move left instead of moving right. All right, let's go ahead and take a look at number 19. On number 19, what we would need to do to get that y by itself is we'd have to divide everything by a -3. So in this case, that's going to become a +1. Here, we're going to end up with 4/3, and the negatives are going to cancel, so it's going to be +4/3 x. Now that's also a little bit backwards, so a better way to write this would be to put the y on this side if it looks more familiar to you, and then our slope with the x, and then the y-intercept. Okay, so if it helps you to rewrite it, you can. You don't have to do that last step, but you can. All right, so I'm going to start at 1. My y-intercept is 1. Then I'm going to rise 4, and then I'm going to run 3. And there's that one. All right. And then the last two are examples where we don't have an x and a y. We're missing a letter. When you have just a y, that's a horizontal line. So what you're going to do is you're going to find where y equals -3 first. And you're just going to draw a horizontal line. If you ever have x equals 5, you're going to find where x equals 5. And then you're going to draw a vertical line. Okay? And that's how you graph those types. We talked about how these ones have a slope of 0, and these ones over here have a slope that is undefined. Okay? And so that'll end our study guide for Unit 1, Quiz 1 Study Guide help video. So hopefully that was helpful to you guys, and we'll see you in class.